When we have a quadratic, we have standard form, which is what we're used to, the x squared, ax squared plus bx plus c. And we have vertex form, the a parentheses x minus h squared plus k. When you're in vertex form, it tells you what the vertex is. The vertex of a quadratic is h, comma, k. The h comes from inside the parentheses with the x, and the k comes from the adding or subtracting at the end. The h is just like your x coordinate, and the k is your y coordinate of the vertex, which would be the maximum or minimum of the quadratic. So if we look at this first example, f of x equals x minus 2 squared plus 3, the h is just the 2. Notice in the formula, it's a minus h. So the minus sign does not go with the h. So h is just 2, and then the plus 3 tells you it's a positive 3 for the k, and your vertex becomes 2, 3. That is your vertex. For number 2, notice it's a plus sign in the middle. Okay, but I want it to be a minus sign or a subtraction sign in order to match the formula. So I'm going to rewrite this as 2 times x minus negative 1 squared minus 4. That's how this became a plus sign, because it was a double negative, which changed it to a plus sign. So now my h for this example is a negative 1, and my k for this example is negative 4. So my vertex would be negative 1, negative 4.
Do you have to record it?
No. Okay, so anytime you have a plus sign in the parentheses, it's really the opposite. So if it says plus 1, it really means negative 1. If it says negative 2, it really means a positive 2. Because of this double negative, that made it become a plus sign. So you're looking inside the parentheses only. It's the opposite of what you see. The k is always exactly whatever it says. All right, so if we look at this example and we're trying to find the axis of symmetry on the notes that you just wrote down, h equals the axis of symmetry. So anytime we are finding h, we can find the axis of symmetry. So when this is in vertex form, this would be my a, x minus h squared plus k. That's the formula for vertex form. So the h value is going to be your vertex. Remember that when it's in vertex form, I really want to see a subtraction sign. So if I see an addition sign, it really means the opposite of that because it was a double negative. So my h value is going to be what? Negative 5. What is my k value, just for fun? Negative 8. So my vertex would be negative 5, negative 8. This particular example says I just want to know what the axis of symmetry is. So the axis of symmetry is going to be my h value, and I write that as an equation. I'm going to put ASO for axis of symmetry, which is x equals negative 5. This is an equation. X equals negative 5. That is the vertical line that represents the axis of symmetry. So whatever h is, that tells you your axis of symmetry. If you're trying to find the axis of symmetry when it is in standard form, so this is your standard form, ax squared plus bx plus c. If you wanted to find h, which h tells you your axis of symmetry, you're going to complete the formula of negative b over 2a or b over negative 2a. It doesn't really matter where the negative is, but it's negative b over 2a to find h, and h tells you the axis of symmetry. All right. For this example, it says to consider the function f of x equals 2x squared minus 4x plus 5. Determine whether the graph will open up or down. If A equals a positive 2 is a happy number, so it would open up. To find the axis of symmetry, we have to find the H. In order to find H from standard form, we have to do negative B over 2A. So from my formula over here, my B is negative 4, so I'm going to have negative 4 over 2 times my A, which is 2. And when I simplify that, I get a positive 4 over 4, which equals 1. So x equals 1 is my axis of symmetry. All right, the next part C, says to find the vertex. So it's the same formula. And at the last slide, we found that H was equal to 1. Well, the vertex is HK. Okay? So we have H is equal to 1. This is your X value. So since I know what the X value is, I can plug it in for X and solve for Y. So I'm going to take my H and I'm going to plug it into the equation. So now I have to find K, I'm going to plug in 1. So 2 times 1 squared, I'm pulling that from my first term, minus 4 times 1, that's my second term, plus 5. When you solve this, follow your order of operations. 1 squared is 1. 1 times 2 is 2. 2 minus 4 is a negative 2. Negative 2 plus 5 is 3. So your K is 3. Again, the vertex is HK. So that means my vertex would be 1, 3. And finally, the y-intercept is your C. So your C is always your y-intercept. So your y-intercept for this problem is 5. All right, for this example, we have f of x equals negative x squared plus 2x plus 3. So first question, part A, is to determine if it opens up or down. You look at the A value, which is negative 1 for this problem, and so it is going to open down. Okay? To find the axis of symmetry when it is in standard form, we have to do the negative B over 2A because it's in standard form. Our B for this problem is a negative 2, so I'm going to plug in negative 2 over 2 times my A, which is negative 1. That becomes a positive 2 over a negative 2, which is a negative 1. So my axis of symmetry is x equals negative 1. That is also the H value of the vertex. That is the H value of the vertex. No. Okay, now we have to find the vertex. The vertex, we're going to use the H value from the last slide, which was negative 1. The H value of the vertex from the last slide was negative 1. We got that because we did the negative B over 2A. H equals negative 1. Now we're going to plug that into the formula, or to the equation, and find our K value. Our K value is going to be negative 1 squared minus 2 times negative 1 plus 3. We plugged in our H into each x value of the equation. Negative 1 squared is a positive 1. Positive 1 times negative is a negative 1. What happened there? Again, negative 1. This becomes a plus 2, plus 3. Keep simplifying. This becomes 1 plus 3, which equals 4. So our K value is 4. So our vertex is HK, which is negative 1, positive 4. And our vertex is -1, +4. And the y-intercept is the C, which is 3.